Thanks for coming at the nice 2 o'clock hour. This is the best time right after lunch. Everyone's really ready for a talk right now. Okay, so today we're going to talk about constraint layout. And I'm going to start with the basics, and we're going to kind of review what we've introduced with Constraint Layout 1.0, Constraint Layout 1.1. These are the things that you can use in production today. And then later, the second half of the talk, I'm going to talk about some of the new features that are going to be coming out in Constraint Layout 2.0. Now, before we get started, who is already using Constraint Layout to design views? Okay, so about half the room, and about half the room is going to be learning a bunch of new material. And if you already know everything, hopefully the slides are pretty, and my presentation is good too. So what is constraint layout? So constraint layout is a view group. It's just like linear layout or frame layout, but it's for taking a collection of views and figuring out how to organize them on the screen. So when we start out with, we add a view to the screen. So I'm going to add just a single text view to the screen. And we see just a bunch of controls show up in the design surface on the Visual Designer in Android Studio. So you can see there's a bunch of anchors on the top, bottom, left, and right of every single view that you're going to add to the Visual Designer. And then over on the right, we have the attributes pane. So the attributes pane has a whole bunch of stuff. I've selected the stuff for this talk that is relevant. So we have the width and the height. So every view obviously has a width and a height. And then we have this thing, it's called a view inspector in the documents, but I just call it the thing on the right. So we have this thing over here which shows what this is. This is wrap content, and this is wrap content. And then these things right here are what lets us build constraints. So let's go ahead and add a constraint. Right now, we haven't put any constraints on this view. It's inside of a constraint layout. It basically just means constraint layout doesn't know where to draw it. It's just going to go somewhere on the screen, probably not where we want it. So we're going to do that by grabbing this handle here or clicking that button there. And then when we add a constraint, what we're doing is we're telling constraint layout this view has to be 30 dp from the top of the screen. So this is one of the constraints that's required in order to display this screen. We can add another constraint over here. Let's make that 7. So we have now bound this view. It's constrained to the top of the screen, and it's constrained to the left of the screen. So when we do this, constraint layout now knows how to position this view. If we run this app, this view is actually going to show up on the screen. It's going to be in the position that we expect it to be. So constraints have, basically they have a margin. So here we have the 30 dp margin. We can adjust that. We can make that 50. And that's how we move views around with constraint layout. We can also move that up to 0. And this is really, really common with constraint layout. So if I put just the top and left at 0, what I'm going to get is, it's going to move up to the top left. I don't think that's too much of a surprise. But when I start adding more zeros, I'm going to center the view. So when I added a 0 on the right side here, we end up centering the view. And if we do the same thing on the bottom, that's how we center view as well. So I want to talk for a moment about the targets of constraints. So the targets of constraints, so far, we only have one view. So the targets of constraints are always the side of the screen, because that's the only thing that we have available. When we add a second view, we're going to be able to constrain things to other views. And then margins, of course, are outside of the view. So that's what constraint layout uses to position a view. And then if you have padding on your views, that's inside of the view. So constraint layout discards that. It's counted as part of the size of the view. There's one more kind of interesting element to constraint layout, and that's called a constraint bias. And that's these sliders on the side of the view inspector. So the constraint bias, by default, is 50. So what that means is when I have a constraint on both sides, and I'm pulling equally to the top with 0 and to the bottom with 0, I'm going to position that 50% along the way. If I move that up, it's going to position that 25%. And if I move it down, it's going to position it towards the bottom of the screen. So I can use this to affect the bias of a view that's being laid out by mutual constraints. And there's, of course, a horizontal bias as well. So we talked about this a little bit earlier. The view inspector over here has a visual display of this exact content up here. So we have layout with wrap content. So this is the default when you drop a view in. There's 3 other options in constraint layout. And this is a little bit different than what you have outside of constraint layout. So wrap content obviously works the way you think it does. It wraps the content, it fills the view space. We can also set that to be a fixed width. So this isn't too exciting. We can set this to 100 dp, and it's going to display exactly the same way. Now, where this gets interesting with constraint layout is we can also change that to match constraints. And what match constraints means, it's kind of the same thing as fill parent, sorry. Match parent, sorry. It's almost the same thing as match parent, but it's a little bit different. So what it says is, I would like to expand this view to fill the entire area that's allowed by my constraints. And since I'm only constrained off the side of the screen right now, I'm going to expand to fill the entire screen. But later we're going to add more constraints, and we'll see how we could use that to constrain to smaller areas. Now, one thing about constraint layout, you can specify the width or the height of view as match parent. Just don't do it. It's an incorrect thing to do. You always want match constraints. So let's go back to wrap content. And let's add another view and see how we can use constraints to put views together. So I just dropped an image view onto the screen. Where's my slide? Moment. I've broken Keynote. There's too much magic move in this deck. So I've added an image view. I'll describe it while my computer figures out what's going on. So I've added an image view to the screen. Just like before, it's not constrained to anything. And I would like my apologies. It's an image view. OK, fantastic. OK, so I've added an image view to the screen. So we're going to go ahead and constrain it. So valid constraints, as we talked about before, we can constrain to the side of the screen. But if that's all we could do, we basically just made absolute layout. We can also constrain views to each other. So if I make a constraint from the image view down to the top of what are constraints, I'm able to say this image view always has to be above what are constraints. So that's basically what that constraint does. Then if I add one over on the right here, it says this right edge right here has to be exactly aligned with the right edge of the what are constraints view. And if I add one more constraint over on the left side, it's going to go ahead and center that. So this is exactly the same thing as we did before when we added constraints to the edges of the screen, except now we're using the sides of this view as the constraints to the right and the left. So this is a trick you're going to be able to use over and over again to lay out screens with constraint layout. It's basically the way to center things is to put two constraints on both sides of your view. Bias would work here as well, so you'd be able to move right or left. So if I go to the layout width, I can change the layout width to match constraint. And when I do that, we'll see the view will expand to the entire width of the text view. And it'll actually track this text view. If I change the text on this and we change the width of this text view, the image view is going to change size with it. And when I do that, when I change that match constraint, I get this kind of interesting control right here. It's not super intuitive graphically, to be entirely honest. So this turns into a line when it's an image view. This is all only for image views. And then you get this little triangle right here that shows up on the view inspector. And this shows up anytime one or two dimensions match constraint. So if I click that, what it's going to do is it's going to constrain the image to use aspect ratio. So when you're working with a designer and you're chopping a screen the designer gave you, a lot of the time they ask for specific aspect ratios, but they also want it to adjust manually, so they can fill with different size images and the aspect ratio will be maintained. This is the way to do that without writing all of the code to do everything I just said. So this is really awesome. I love this feature. So by default, it's constrained 1 by 1. I can change that to 2 by 1. There we go. I can change that to 2 by 1, and now it's 2 by 1. I can make it 16 by 9, so this is a common aspect ratio. But if I try to make it 3 by 1, it's actually wider than the constraints allowed by this text view here. So this is actually kind of interesting. What happens here? Who wins? Does the aspect ratio win, or does the text view constraints win? And it turns out the constraints win. The constraints say it can never be wider than this, and then the aspect ratio tries to make it fit that aspect ratio. So I can go up. If I want that to work, I can change the layout height to also be match constraints. Because we have the ability to calculate an aspect ratio that fits here, but not will we have height of wrapped content. So if we change that to match constraint, the image view will adjust its height in order to maintain the aspect ratio that we asked for. OK, so that's the basics. That's Constraint Layout 101. Let's take a look at a real view and talk about how we might actually design that with constraints. So here's a really simple email, password, login, new account form. And to be clear, this is not a talk about how to design a login form. There's many, many problems with this login form, but it's good for talking about constraint layout. So one thing to look at here, we have right justified email and password, and then left justified actual email and password on the right side. And then down at the bottom, it looks like login is constrained by the right of the password. And then at the same time, we can see the email and password are centered on the screen. And then login and new account drop down below those. So these are all things that we're going to have to be able to build with constraint layout. So before we get there, let's talk a little bit about how we actually lay out email and me@gmail.com. What is the orientation that we want to hit there? And what is it our design team is going to be looking for when we build this screen? So there's a couple metrics on fonts that you probably are already aware of, but let's just review real quick. So we have a baseline right here. So the baseline in most fonts is the line that everything except a couple things sits on top of. So if we had a Y over here, it would go down below that baseline. But almost everything sits above the baseline. Then there's the ascender line, which is nothing goes above that. And then there's the descender line, which is the thing that the Y goes down to. And the baseline is the really important one. It turns out that visually, that's actually the only line we really need to care about when we're laying out text of different sizes next to each other. So if I try to lay out me@gmail.com next to email, these are obviously wildly different font sizes. This looks like it's a line of text if I align the baseline. So constraint layout supports that natively. So when you select a text view, there's this little control that shows down below the text view. It looks like that. I've enlarged it substantially in order to show the texture of the product. And when you click it, it creates a flashing green orb. I don't know if there's a technical name for that, but I call it the flashing green orb because it actually has a blink going on in Android Studio. It's probably my favorite control we've ever shipped. So if we go over to the email address over here, and we hit the same thing, we're going to get another one of those flashing green orbs. And then we can drag between those two and create a constraint. And this says that the actual email address over here should have its baseline aligned to the baseline of the text on the, for email. And we're going to go ahead and do the same thing for the password row and the same thing down here. And it turns out anytime you lay out text along a line like that, you pretty much always want to be aligning the baseline. That's just the correct design choice to make. Interestingly, I'm actually going to make new account follow from login. Because if you look at this design fairly closely, you'll see that new account isn't really bound to the right side over here, but login is clearly bound to the left side. So that's something that we're going to be working with a little bit later. And it shows how you can kind of switch between things as you lay out your designs. So to make new account and login actually get displayed there, we need to go ahead and constrain those. So we'll just put a constraint between login and the password field. And then to make and then we want to center the whole thing. We want to center email and password. So we'll go ahead and add a top constraint to email. And we're going to give that 0, just like we did before. And that's going to pull the email up to the top. And we have we have those baseline constraints, so all of the horizontal lines are going to stick together. And we'll take password now and add a 0 there, because that's how we centered things before. But this isn't quite the view we were looking for. So now we have email on the top and password on the bottom. So we're obviously going to have to add some sort of constraint between these two. So if we add a constraint from password up to email, we're going to go ahead and pull password up. But now all of our views are centered, well, not centered. Now all of our views are attached to the top of the screen. And if we add a constraint back down, it's going to go ahead and center that off of both views. And this is what's called a chain in Constraint Layout. So what this does is it takes all of the views and then it tries to center based on those views. It turns out you don't have to draw all of those lines with Constraint Layout. So if you go into the helpers, so we select email and password, there's a center option. So we select center vertically, and it'll create all of the constraints that we just laid out right there. So there's 3 different types of chain styles. So there's spread. So this is going to evenly distribute your views across the constraints. Then there's spread inside, which takes the first and the last view, expands them out to the edges. And then there's packed, which tries to put all of the views as close as possible to the center while maintaining the constraints. And so here, obviously, we're going to be using packed. So now we need to right justify these text boxes. So we have email and password, and they have to be constrained off of something. I can't take a constraint from email over to the edge of the screen and a constraint from password over to the edge of the screen. That's not going to work if those fields change size or if I go to another language. What I can do instead is use a helper. This is in another context menu. So I can add a vertical guideline. And what a guideline is, it's basically just another edge of the screen, is the way to think about it. So it's a line that I can put anywhere on the screen by a percentage of the screen. And it's an anchor for constraints. So I can use this by moving that to where I'd like to right justify the text. And now I select all of my views, and I add constraints from these views to the guideline. And then once I do that, you'll see that all of these views are based entirely off of this guideline. To demonstrate that, we can move the guideline. And you'll see all of the views go with it, because now we've constrained every view to be constrained off of this guideline. If we go to the left, it does the same thing. And back here. So I'd like to change the layout quite a bit now. So previously, we right justified email and password, and we used a guideline for that. Now I'd like to left justify email and password. And this view, it works fine in English like this. And I think we could figure out how to constrain this. But I'm going to go ahead and get some German translations back from the translator. And it's going to look like this. Now, I'd like to take a moment here and mention, I think there's like a secret cabal among all the translators to choose the largest possible translation when they give you German strings back. This says a new account create for new account, which is it's my favorite. So this is obviously not working. So my views are overlapping. Things are going off the left of the screen. So what happened here? So if we go back and we take a look at the English version of this, if imagine we're going to add constraints to it, we'd take a constraint and add it between the password to the password, because that's the largest word in English. And then we can just constrain the left sides of the two things on the right. And this is going to work great in English. And of course, when we go over to German, password is no longer the longest word. So this isn't going to work at all. So we're going to need something that figures out what the longest word is. So we're going to go back into helpers. And there's another helper to add a vertical barrier. And this is similar to a guideline, except it's based on a couple of views. So how do you do that? When you add a barrier, you have to go over to the component tree. It's over on the left-hand side of the visual editor. And the component tree shows all of the components in a tree. It's pretty straightforward. It's named off of what it is. So here we have a constraint layout. It has email, password, and everything else going on there. And then we've added this barrier down on the bottom. So what we do is we select email and password. These are the two things we'd like to be working off of. So we select email, select password, and then we drag those down to the barrier. And then the barrier moves to the left of those two views, which is not quite what we wanted. So if we go back over to the attributes pane now, and we scroll a little bit down, we'll find that the barrier direction is set to left. And what this means is it's going to take all of these views, lay them out, figure out what the leftmost position of all of the views are, and set the barrier at that point. We can go ahead and change that to end, and now it's going to take all of those views, lay them out, figure the rightmost position, and then it's going to set the barrier at that point. So now this behaves just like a guideline before, except it's constrained off of email and password. So we'll just go ahead and lay out the constraints for the email and password like that. And when we switch to German, it's going to go ahead and reflow the entire screen. So this is how you deal with kind of tricky views that change size, like email and password is a classic example from German. So that's it for basics. At this point, I want to take like a moment and talk about like when to use Constraint Layout. So Constraint Layout's obviously great for laying out complex views like we've done so far. These would all, if you did these in linear layout, involve multiple levels of nested linear layout. That's fantastic. Does that mean you need to use Constraint Layout everywhere? And the answer to that is just clearly no. If you have just a list of things that fits in a linear layout, go ahead and use that. If you have things that fit into a grid view, use that. Places where Constraint Layout works really well is when you have things that would require nesting in a linear layout. For composing the entirety of a screen, and recycler view items. Recycler view items very typically have lots and lots of complex design going on inside of them, and they also need to be very, very fast. So now let's switch and take a look at some of the new features that are coming out in 2.0. I think the big one, at least for me, the one that I'm most excited about is motion layout. So this is a demo that Chris Baines published just a couple days ago, showing a view that you can build in motion layout. So there's no coordinator layout involved in this at all. So this is all done in motion layout. This is all done in constraint layout. So taking a look at this, I mean, we can see pretty clearly, like you can imagine, these are all the constraints we talked about before. These are just stay. These are all just based on basic constraints. You can see some chains in there. And then there's a recycler view of elements down at the bottom. So what can you build with motion layout? You can build collapsible headers. So we just looked at that. And this is, for me, this is like one of the hero use cases for motion layout. Collapsible headers are somewhat difficult to build before motion layout. And with motion layout, they're relatively easy to build. You can build state feedback. So if you have state that goes from A to B, perhaps you go offline, online, and you'd like to do some sort of animation where there's a start and an end. It's a really, really good solution for that. It's great for transitioning a bunch of elements around the screen to create a new scene. And this presentation, like almost all of the animations I've done in this presentation are possible to build in motion layout. Now, the key to understanding motion layout, like actually, if you only take away one thing about motion layout, is animations have a start and animations have an end. And that's all you have to specify. You say, my animation starts with one design and it ends with a different design. And then everything in between is motion layout's problem. So let's take a look at this, kind of like animations 101. So I have a dot, and I'd like to animate it. So it has a start, which I'm going to define via constraints. So I'm going to use constraints just like before to the top of the screen and the left of the screen. And then it's going to have an end. So these are another set of constraints that I'm going to define, where I constrain to the right of the screen and the bottom of the screen. So this is my problem. I have to define the start and the end. I have to say where my animation begins and where my animation ends. And then constraint layout's job, motion layout's job, is to take the start and figure out how to get to the end. And this is called tweening. So what it's going to do is it's going to figure out a path from start to end, and then when you ask it to animate, it's just going to go ahead and follow along that path. And so an animation is really just a start and an end over time, if you just add all of it together. And I just want to repeat this just for the 8th time. An animation consists of a start and an end. And everything in between will be tweened for you. Sorry, I couldn't resist. So how do you make a motion layout? So a motion layout is, it's a layout just like constraint layout. It's a subclass of constraint layout. And then what it does is it points to a thing that's called a motion scene. And the motion scene is where you say what the start and the end are. A start and the end are defined via constraint sets. So a constraint set is a little bit different than a constraint layout. So far we've talked about constraint layout. I've shown these diagrams where there's a bunch of views. These are all text views and buttons. And then there's a bunch of constraints going on at the same time. And so this is a layout plus a constraint set. When I have a constraint set, it's just this part. So a constraint set specifies the height and width of all of the views. And it specifies how the views are constrained to each other, but it doesn't actually contain the views itself. It's just references to the view IDs. And so we actually saw an animation you can do with motion layout earlier in this talk. So we can use this to build a motion layout. If this is the start and this is the end, that's it. Motion layout will deal with figuring out how to move that. And all I had to do is set the constraints on that guideline and move the guideline across the screen. And when that renders on the screen, it's going to look something like this. So let's take a look at a realistic example of something you might want to build with motion layout. This is like a very simple design, specifically so that it's easy to build for this talk. This is something we actually demonstrated for a different version of constraint layout, this animation here. You can see that the top header just moves in, and then the bottom header comes down with it. And then the bottom description text on the bottom is just coming up. And this is a nice reveal animation. It's pretty bold, and there's just a couple things that are moving around on the screen. So let's take a look at how we would implement something like that. So we take a motion layout, and so in the motion layout, we're going to define all of the views. So we're going to put the title, we're going to put the subtitle, and we're going to put the description, and we're going to put that image view in the background. There's no constraints in the motion layout itself. So motion layout is like a constraint layout in that it's a subclass, but instead of specifying all of your constraints in the motion layout, we're going to do that over in the start and the end. And then we make a motion scene. So this is that other thing. This is where we say what is the start and what is the end. And this is where we're going to define all of our constraints for our motion layout. So in the start, you can see that we have no constraint over on the left, and then we actually put a little constraint from the right side of the title to the left side of the screen. And this is what we do in order to push that title off the screen. And we'll do a similar trick with the description down on the bottom. We're going to put a constraint from the description down below the screen, somewhere down there, into the bottom of the start. And then over on the end, of course, this is our final layout. So we're just going to lay everything out like we would before. So the GUI builder for motion layout is not yet released, / is currently being worked on frantically to get it out the door. So I don't have screenshots of a GUI builder or slides of a GUI builder, so we're going to have to look at XML for the rest of this talk. So how do we do this? So I'm going to make a space layout. So instead of a constraint layout up here on top, we're going to change this out, and we're going to use a motion layout. And the only difference between a constraint layout and a motion layout, really, is it has another attribute, layout description, which points to an XML file, which is your scene file. And then inside of this layout, we're just going to define the layout here. We're going to put all of the views in here, but we're not going to put any constraints in here. Then we're going to go ahead and build that motion scene. This is a separate XML file that specifies the start and the end of the transition. It also specifies the duration, and it has a bunch of other features as well that will allow you to build really, really complex and impressive animations. So in order to define the start, this is still in that motion scene file. I am going to make a constraint set. I'm going to give it a name, and then I'm going to, in that, define a whole bunch of constraints. These are the same constraints that we were drawing before with the blue dots in the visual editor, or the blue lines in the visual editor. But now we're going to specify them completely in XML. So we're going to say what view we're modifying the constraint of, and then we're going to tell it the height, the width, and the padding. And in the current alpha of motion layout, you have to specify this on every single constraint in every single constraint set. I don't know if that's going to be in the final version. And then you give it the constraints that you need. And the interesting one here, and we talked about this earlier, is we're going to constrain the end of the title to the start of the parent. So that's going to move the title off the screen. And we're going to repeat that for every single view in this layout. We're going to provide one of these constraints for every single view in the layout in order to define our start state. And then we're going to go ahead and define the end. So we're trying to build this thing over on the right. So we're going to give it the Android ID of end. And then everything else is the same. The only difference is I'm going to constrain the start to the start of parent. So now I've moved that title onto the screen, which you can see visually up there on the top. I'm going to repeat that again. I'm going to repeat that for every single element on that screen. And when I've done that, I'm going to have created this animation. So all I have to do then is just say motion layout.transition to end over in my Kotlin code, and it's going to go ahead and trigger that animation. So again, for the, I think, 10th time now. So in order to define a motion layout scene, the thing that you need to remember is you define the start, you define the end, and that's all that comprises an animation. And then in between is motion layout's problem. If you want a more complex layout, more complex animation, if a linear path like I've shown there isn't going to work for you, you can also transform that path. But I'm not going to cover that today. That's something you should take a look at these amazing blog posts that Nicholas has published on Medium. So he put together a 4-part series. I think he has another one planned. That covers the basics of motion layout. So if you want to dive in further and see some of the other features that motion layout has, definitely check these out. These are really, really, really good posts. And then Chris Baines just published this fairly recently. This is a really, really good demo. It shows some of those keyframes that I was talking about in the middle where it modifies the path. And it's it's very easy to follow along what this is doing. I definitely recommend checking this out if you'd like to see an in-depth sample of the sort of things you can build. Another thing you can see in this is that motion layout allows you to handle touch events, which is really, really cool and allows you to do things like build collapsible headers. If you don't want to follow along with the alpha releases, if you just want to know when it's released, follow Android Dev on Twitter. That's definitely the best way to learn about this. We're going to tweet constantly about motion layout when it's released, I think like at least every week. And Constraint Layout 2.0 is currently in Alpha 2. So you can just put that in a project, and you have motion layout available right now, as well as all of the other new 2.0 features. So you can go ahead and play with those, and please file bugs if you start playing with them. If you find things that are weird, if you find you're writing lots and lots of boilerplate code, go ahead and let the team know so that they can get those fixed. So I think we have a couple minutes left for questions. Does anyone have any questions about constraint layout or motion layout? Uh-huh.
So doing that seems something like you would get a circle dependency, like how you had like the email and the password.
Yeah.
So how does that avoid that situation when you're doing the chain?
It is a circular dependency. So it's like intentionally a circular dependency, and then it's coded such that it detects the circular dependency and treats it as a chain instead. So that is how chains work, is you set up a circular dependency, and then it uses a different layout engine to figure out how to lay out the chain.
Yeah, but it's okay to do it with constraint layouts, because I know if you do it like in a linear layout, it crashes.
Yeah. So it's okay to do that in constraint layout. It's by design. They intended it to work that way. Yeah. Yeah.
Is there something like stack views being worked on where you could have this flexible stack and the stack has constraints, especially for things like that Stranger Things screen example we showed where there's a row of icons and there's a subset of information under that. It's like neatly stackable things. Is there anything because for the most part you want the items in the stack to maintain these like very low-end rules of just like maintain equal space and be of this size.
Yeah.
Stacks that needed to be vertically spaced from each other.
So I would say, so building that entire screen for that, it was fairly complex. There was lots of little parts. For something like that in particular, there was like there's some icons. There's like this row of icons that was equally spaced. It's obviously possible to build that in constraint layout with a chain. It's also totally reasonable to just go ahead and put a linear layout in your constraint layout to build something like that. And that helps, I think, reduce the complexity of a larger screen, is to build subcomponents and put those inside of the constraint layout. Does that answer your question? Yeah. Okay. And I saw another question here. Yeah.
So I know that the idea is with using constraint layout is a bit of the autonomous level, right?
Mm-hmm.
And in order for it to work well and to do all the layout and computing.
Mhm.
and I'm trying to migrate to constraint layout, like, in steps.
Mhm.
What are the effects of having it nested within the?
Yeah, so you're saying about like constraint layout in constraint layout, maybe in constraint layout, or just one level?
Like having like a different type of map or linear or something like that, and then inside having a constraint layout.
Okay. So linear layouts, obviously, you want to avoid any situation where linear layout's going to do a lot of layout. So that's setting the layout weight in your linear layout. If you have constraint layouts nesting, there's a situation to avoid there where you use wrap content all the way down. Because every time you do a wrap content, it has to do 2 layout passes. And each sub-level, it might have to like tell its parents, and you end up with this 2 to the level of depth layout passes. So if you have 3 levels, you have 8 layout passes, for example. So you just fix that by either match constraints on the wrapper view, or just giving it fixed width, maybe to the sides of the screen or something like that. So it's completely realistic, especially on the full screen constraint layouts, to have a couple levels of nesting. That's probably not going to be a problem. I mean, obviously you have to check on a real phone to make sure that your performance is acceptable. When you're in a recycler view and you have like 15 items on the screen, you probably don't want to have high levels of nesting, because that's a situation where you're going to want really efficient layout passes. So yeah, it's totally okay. The thing to worry about is just less nesting wrap content, wrap content, wrap content, wrap content.
Right, and we're talking about just like performance issues, right?
Yeah.
Like anything about like bugs with the constraint or how it calculates or anything like that.
So if you put a linear layout in a constraint layout, that's just going to be one view, and then all of the views inside it are fine.
Constraint layout inside.
And it's the same situation. If a linear layout has defined a space for the constraint layout, and then you put a constraint layout that fills that space, it's going to be fine if it's not the full screen.
Is this a good way for like? Do you think it's a good way to migrate like very complex views or?
Yeah, I think piecemeal migration is always the best way. And I think the risk there, I guess, would just make sure that the code is always in a good state along the way. Yep. Okay.
In general, if you put a very much simpler view inside of a constraint layout view, you're going to actually get to faster rendering than if you actually try to develop a constraint layout. And probably, and the same is also,
I would say a little faster rendering, not much faster.
It depends. Like sometimes it all depends how complex it is. One of the nice things about constraint layout is actually it's different solvers. They solve a lot of those simple cases very quickly.
Mhm.
So even though it might seem like it's going to be slower, it's actually not much slower.
All right. Thanks, everyone. It was super great to have this talk today, and thanks for coming.